increasing heat transfer. So logarithmic mean temperature difference. Logarithmic mean temperature difference. Okay, when two plates are one body is here, temperature T1, T2, and you want to calculate heat transfer rate. So like Q equals minus Ka delta T by delta X, right? dt by dx. But what happens if temperature is varying? Then what is the simple formula? So in that case, we consider two cases. One will be parallel flow case and another counter flow case. So parallel flow means like I have one pipe inside another pipe. Okay. No. Let's say I have one pipe over another pipe. Okay. And this direction flow and this direction flow, this is parallel flow. And in another case, I have inner pipe, outer pipe. Inner pipe flow like this, outer pipe flow opposite. Okay, this is counter flow. Okay, so what happens in parallel flow? If I plot it, so this is T hot 1, T hot 2. So let's say outer pipe is having initial higher temperature T hot 1 and lower temperature T2 and T cold 1 through inner pipe T cold 2. Okay, so T hot 1. So if both fluid are going through concentric tube and continuously flowing, so what will happen? Hot fluid will be releasing some heat and temperature will be going down. Okay, so T hot 1, T hot 2. And what will happen? Cold fluid will take certain amount of heat. Okay, so if fluid is flowing like this, then hot fluid will be releasing heat, cold fluid will be accepting heat. We are assuming there is no heat loss, okay, from other way. So what the amount of heat absorbed by hot fluid will be same as amount of heat released by amount of heat released by hot fluid, T hot, T cold. Amount of heat released by hot fluid will be absorbed by cold fluid, same amount. Okay, so in this case the formula becomes Q equals U A delta T or it becomes delta T becomes Lmtd. Okay, logarithmic mean temperature difference. So how this Lmtd calculated? Lmtd formula is that equals del T2 minus del T1 natural log of del T2 by del T1. Okay, this is del T1 del T2. Okay, this difference. So del T1 equals TH1 minus TC1, del T2 equals TH2 minus TC2. Okay, this is the logarithmic temperature difference. So now my Q equal be UA is equal to UA Lmtd. Okay, this is for parallel flow. For counter flow, what will happen? Let's draw again the similar figure. So what will happen? Let's say T hot entering, T hot exiting, T cold entering, T cold exiting. Okay, so T hot entering, so this side, right? So hot entering and it is becoming, temperature will be down. Okay, so temperature down. Okay, now T cold left side entering, T cold entering and temperature will be increasing. Okay, so T hot entering, T hot exiting, T cold entering, T cold exiting. and del T1 del T2. In this case, del T1 equals T hot 2 minus T cold 1. Del T2 equals T hot 1 minus T cold 2. Okay, so but my LMTD formula does not change. LMTD will be as it is. Okay, so this is case LMTD, logarithmic mean temperature difference equals del T2 minus del T1 logarithm del T2 by del T1. LMTD same formula, del T2 minus del T1 logarithmic del T2 by del T1. Okay, both formulas same actually, only the representation. So this is a very common problem in mechanical, chemical and other engineering. So you should not get confused, just you should remember the formula, how it is getting formulated. So problem 6, to insulate wall 3 materials are used. Please see the figure. The outside brick wall has a thickness 23, 2, 3. Okay, the other two layers plastic or foam, okay, 0.08 and 1.5 centimeter. This is centimeter. 0.02, okay, meter and centimeter. Just please see the unit, actually it is mix of unit is given. Outside temperature, inside air temperature given 22 minus 22 degrees centigrade. The inside outside heat transfer coefficient 29, 12, and thermal conductivity brick 0.9, 0.02, 0.17. Determine rate of heat remove refrigerant Q. Okay, so we are assuming this is inside temperature, is it is for refrigeration purpose used, maybe cold storage application. The temperature of the inside the surface of the brick you have to calculate. So formula is that 1 by U equals 1 by HO plus x1 by k1 plus x2 by k2 plus x3 by k3 plus 1 by hi. So it is becoming 1 by 12 plus 0.23, 0.98 plus 0.08 by 0.02 plus 1.5, 100 into 0.17 plus 1 by 29. So this is giving 4.4407 meter square K per watt. So you can see this heat transfer analogy, electrical analogy. TO, T1, T2, T3, T4, Ti, Q heat transfer rate R1, R2, R3, R4, R5. Okay, so U becomes 0.02252 watt per meter square K. So R1 plus R2, 1 by HO plus x1 by k1, 1 by 12 equals 1 by 12 plus 0.23 divided by 0.98 equals coming 0.318. Okay, now TO minus T2 equals 486.4 into 0.318 divided by 90 equals 1.72 degrees centigrade. So T1 equals 22 minus 1.72, T equals 20.28 degrees centigrade. So hot air at temperature 60 degrees flowing through steel pipe 10 centimeter diameter. Okay, the pipe is covered with 2 layers of different insulating material. Material of thickness 5 and 3 centimeter, and corresponding thermal conductivity 0.23, 0.37, watt per meter K. The inside and outside heat transfer coefficient 58, 12, 12. The atmosphere is 25 degrees centigrade, 25 degrees centigrade temperature. Find the rate of heat loss from 50-meter long pipe. 50-meter long pipe. Q we have to calculate. Okay, neglect resistance of steel pipe. So R1 equals 5, R2 equals 10, R3 equals 13. Okay, K1 equals 0.23, K2 equals 0.37 watt per meter K. KHI equals 58, HO equals 12. Okay, TI is given 60, TO given 25 degrees centigrade. So Q equals 2 pi L TI minus TO 1 by HI RI plus 1 by K1 logarithm of R2 by R1 plus 1 by K2 logarithm of R2 by R3 by R2 plus 1 by HO R3. Okay, so this value, if I put all the values, 2 pi 50 60 minus 25 1 by 58 into 0.05 plus 1 by 23 logarithm of 10 by 5 plus 1 by 0.3937 logarithm of 13 by 10 plus 1 by 12 into 0.13. So this value will be coming 2334 watt. So it is coming 2.334 kilowatt. Okay, so water flows inside tube of 5 centimeter diameter, 3 centimeter long, and velocity is 0. meter per second. There will be heat transfer coefficient. Heat transfer coefficient and heat transfer rate. The mean water temperature 50 degrees centigrade. Isothermals wall is 70 degrees centigrade T wall, and K value 0.66 watt per meter K. So no need to change units. Viscosity equals 0.478 meter square per second. Prandtl number also given 298. Okay, Prandtl number non-dimensional number. So Nusselt number equals 0.023 RE 0.8 into Prandtl number 0.4. Use this formula. So HD by K equals 0.023837700. Because RE value I have to calculate. RE equals UD by mu. So this will be 0.8 into 0.05 divided by 0.478 into 10 to the power minus 6. So 83700. It's a non-dimensional number, so there is no dimensionality here. 0.8, 2.98, 0.4. So this would be giving H value equals 4075 watt per meter square K, where D equals 0.05 and K is 0.06. K is 0.66. So finally Q become HA T wall minus T that outside temperature, fluid temperature. So it is becoming 4075 into pi 0.053 into 20. So it is coming 38387 watt equals 38.39 kilowatt. So in okay, so this one Lmtd counter for counterflow. So counterflow, first you draw this curve. Okay, so this is given 80, this is given 40, hot fluid temperature, cold fluid temperature 40, 20, 20 to 40 increasing. So del T1 equals 80 minus 40 equals 40. Del T2 equals 40 minus 20 equals 20. So Lmtd equals del T1 minus del T2 by logarithm of del T1 equals coming okay. So Q equals MC del T equals UA LMTD. Okay, so equals 1000 into 3600 into 280 minus 40 equals 0.25 into A into 28.285. Therefore A equals 1000 into 2 into 403600 into 0.25 into 28.85, so equals 3.08 meters square. So again it is counterflow heat exchanger. So counterflow exchanger means first you draw like this. Okay, so it is given heat gain is heat loss. So MHCP 430 minus 330 equals 2.5 into 4.2 T2 minus 280. Okay, so therefore T2 equals 300 K. This is T2. Sorry, T1 T2. Okay, T cold one I can write. Okay, now Lmtd 430 minus 300 minus 330 minus 280 by logarithm of 430 minus 300 by 330 minus 280. So it is becoming 83.33 K. So heat duty equals UALMTD. So therefore 1 into 2.1 into 100 equals 600 into A into 83.33. Therefore A equals 210 into 1600 into 83.33, so 4.20 meters square. So saturated steam temperature T1 equals 90 degrees centigrade, Q equals UA del Tm. So U 2 pi R L del Tm. So 1200 given 2 pi into 0.01 into 0.4 into 90 minus 80 in 0.96 watt. Now enthalpy change from saturated steam to condensate del E equals 2660 minus 375 equals 2285 kJ per kg. Okay, let the rate of steam of condensate be kg per hour. So Q equals rate into enthalpy change. So M cross del E. So therefore 150796 equals M into 2285 into 1000 divided by 360. Okay, therefore M equals 2.375 kg per H. So this is a very simple problem I left for you. Let's see what is this. This is counterflow again. Okay, so 30, 50, 100, 40. So answer I will be writing here, so you can solve it. Equals 36.4 degrees centigrade. Okay, just you try yourself. Again, hot fluid enters concentric pipe, heat exchanger, temperature this one to be cooled. Cold fluid enters this one, calculate LMT counter, both you have to calculate actually. Okay. So this one also you try. This is very simple problem, LMTD formula. Okay. I hope you can solve it. Thank you very much. Thank you very much for listening to the lecture. Next day we will start new topic. Thank you very much.